Vectors. And so first of all, we need to define two things before we deal with vectors. And the first is what a scalar is. A scalar is a magnitude or size of a quantity. So examples of scalar: temperature, time, speed. Okay? A vector is a quantity that has both magnitude and direction. So notice the difference. A vector has magnitude and direction. A scalar is just a single quantity. Okay, so an example of magnitude and direction would be velocity, acceleration, force. So with that in mind, I want you to go ahead and look at this. And it says a boat traveling at 15 miles per hour. So on your expression, I want you to tell me, is that a scalar or a vector? So shouldn't take you very long. Is that a scalar or a vector? And the answer is a scalar. Why is it a scalar and not a vector?
I don't know.
Because of speed.
It didn't have direction, that's right.
Oh.
Okay, a hiker walking 25 paces due west. Scalar or a vector? Answer is a vector, because once again that had magnitude and it had direction. A person's weight on a bathroom scale. Scalar or a vector? We'll see how you do on this one. Woo! The answer is B. Now, this is why it is a vector as opposed to a scalar. Because the force, it's a force, and you're getting a downward force exerted from gravity. Okay? Here we go. A parachutist falling straight down at 12.5 miles per hour. Vector or a scalar? Okay, so that one's a vector because once again the magnitude and direction, because you're falling straight down. Okay, so those are just some examples of vectors and scalars. And so now we're going to get into standard position, direction, magnitude, and true bearings. So if you want to write those down, I'll give you some time and then we'll talk about those. So first of all, up here on the right, this is an example of what a vector looks like. If you look at it, it looks like an arrow, okay, with 2 points. Okay, we have the initial point or the tail. That's my starting point. We have the terminal point or the tip. That's my ending point. Notice it's just like 2 points, A and B. And so if we have a vector in standard position, that means its initial point is at the origin. That's where it starts. Okay, the direction is the angle between the vector and the positive x-axis. The magnitude is the length of the line segment. We denote it by A, and notice it looks like absolute value signs. We signify a vector using a lowercase bold letter. Okay? And then the true bearing, that's a directional measurement where the angle is measured clockwise from the north. It's always given using 3 digits. And we'll talk more about that true bearing later on. Okay, but that's what a vector looks like. And so now, I don't know if you necessarily need to write these down because these things should make sense. Parallel vectors have the same or opposite direction, but not necessarily the same magnitude. So in the figure, A, B, C, E, and F are all parallel. I mean, they look like they're parallel lines, right? So that's why. Those are parallel vectors. Equivalent vectors have the same magnitude and direction. So equivalent vectors in that diagram would be A and C. They are the exact same size, exact same direction. All right, opposite vectors. They have the same magnitude, so they're the same length, but they're opposites. They're in an opposite direction. And so an example of that would be E and A. Okay. Also, would there be 2 other opposite vectors?
No.
There's 2 more.
Well, like B and F. Would B and F?
Nope. E and A, we said. What else? C and E,
Oh,
right. Okay, because you knew that A and C were the same, so that means you can substitute C in for A. Okay, the vector opposite A is written as negative A. So notice by doing that negative, that changes the direction to the other way. So now we're going to talk about finding resultants, and this is what you're going to be doing today. This looks confusing, but it's actually really, really easy. So if you notice what it says, to find the resultant of A and B, follow these steps. So here I have vector A and vector B. Okay? And so how I can do this is there's two methods. There's the triangle method and the parallelogram method. I will use the triangle method. Okay? And so basically I start with vector A. Okay? I draw vector A in. Where the tip of vector A is, that's where I start vector B. Okay? And I'm going to put vector B in. Once I draw those two, I am now going to connect the start of vector A to the end of vector B. That is my resultant. That is how you find the green. Okay. The parallelogram method states that what you're going to do is you're going to put both tails together. So notice here I took both starting points for both A and B together. Then what I can do is I can go ahead and draw another B vector in, and I can draw another A vector in, and the resultant will be this right here, the diagonal across the two. Okay? I actually think the triangle method works a little easier to understand. And then finally, multiplying vectors by a scalar. If a vector v is multiplied by a real number, scalar k, the scalar multiple kv has a magnitude of k times v. Its direction is determined by the sign of k. So first of all, what does that mean? If k is greater than 0, so say for example 2v, all that means is you're going to put two vector v's together. That's it. Okay? If k is less than 0, kv has the opposite direction of v. So if it would be negative 2v, that just means it's going to go in the opposite direction, and I'll show you that on the next example. Okay? So let's go ahead and look at this. It says draw a vector diagram of 3x minus 2i. Okay. Okay, draw a vector diagram of 3x minus 2y. These are some of the first problems on your homework. So what 3x means that you do is that I'm going to take 3 x's and I'm going to put them together. There we go. So do you see how I did that? I just traced x 3 times. Tip to tail, tip to tail. So really, what I have here is x, x, x. Now what I have to do is the minus 2y. So notice a positive y goes up. What's a negative y going to do? Go down. So what I'm going to do now is I'm going to take this right here, and I'm going to flip-flop those. Because remember, we go tip to tail. Here's going to be my starting point. There's going to be my ending point. And that's going to be a negative y.
So the one with the arrow is?
That's your end. Yep, and so now I'm going to do the same thing again, because remember it said minus 2. So then this one becomes a dot. This one becomes an arrow. And there you go. So then now, that's a negative y. The resultant is going to be where I started to where I ended. So how I can draw in my resultant is here's where I started. Oops. Here's where I ended. So that is my answer.
Does that mean you want to use colored pencils on this?
No, you don't have to. I just did this so that you could visually see. So in this case, this would be 3x minus 2y.
Why shouldn't it have been oh, I did my x's.
Okay. So let's go ahead and look at another one. A minus c plus 2b. Okay, so this is actually going to be more than two vectors. A minus C plus 2B. So first of all, I start with what? A. Okay. What does the minus C look like?
Up.
It actually goes up because that's what the minus does. So I'm going to go ahead and place it here, and I'm just going to change that so that this is my starting point, and here's my ending point. So there is A minus C. Now what do? I do two B's. Okay, so I'm just going to take one B right here, and I'm going to take another B right here. And so then now can somebody tell me where my line is, or where my new vector is going to start and where it's going to end?
The tip, like the tail
Mm-hmm.
of the pink.
Of the pink? And it's going to end where?
There you go.
Right. It's where you started to where you ended. That's what you need to remember. Where you start to where you end.
And that's your...
That's my, so A minus C plus 2B, that vector is represented by the orange. Questions? How you're probably going to want to do this on your homework is take your notebook paper and lay it over your book and trace it that way. Because then that way you're getting the correct size and the correct direction. Okay, so the last thing we're going to cover in this section is dealing with components. And I don't know if you necessarily need to write this down. This is taken from your book. And this is actually going to be a review over something we learned way back, like in October. Okay, so it says two or more vectors with a sum that is a vector R are called components of R. So an example in that previous example, A, C, and B were all the components of my final answer. They were all components of that orange vector. While components can have any direction, it is often useful to express or resolve a vector into two perpendicular components. The rectangular components of a vector are both horizontal and vertical. So an example here, she's pulling a wagon. The handle is R, right? When we like to talk about components, we like to talk about the horizontal, which is X, and the vertical, which is Y. Each of those forces is separate. They work together, but they're separate. And so notice when I do that, I create a right triangle. So we're going to look at an example here. Heather is pushing the handle of a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. Draw a diagram that shows the resolution of the force that Heather exerts into its rectangular components. So let's go ahead and look at this diagram. They basically told you, or they show you what you're going to do. I'm going to draw a right triangle in. Here's my right triangle. This is my horizontal. This is my vertical. That's it. And I have a basic, I'm going to put 56 here. I have a basic right triangle. So that's part A. That's all you have to do. Okay? So now it says find the magnitudes of the horizontal and vertical components of the force. The horizontal is X. The vertical is Y. So all we have to do is find X and Y in that triangle. So this is a basic trig function that we've used. Okay, so I need to label. What side is 450? Hypotenuse. What side is X?
The sum
Adjacent.
Adjacent. What side is Y?
Opposite.
Opposite. So let's figure out what trig function I can use to find X. What trig function will be used to find X?
Cosine?
Yep. So cosine of 56 equals x over 450. So now all I need to do is solve that. So to solve that, I'm going to multiply both sides by 450, and you're just going to use your calculator to do this. You need to make sure your calculator is in degree mode and not radian mode. Okay, so remember you go up to mode and you can check to see if it's degree. But what I need to do now is take 450 times the cosine of 46. So what is 450 times the cosine of 46? Or cosine of 56, sorry.
251.64.
251.64, my label will be newtons. So that is my horizontal. Okay? Now I've got to find the vertical. So how can I find the vertical?
Sine.
Yep. So sine of 56 equals x over 450. So to solve that, I'm going to go ahead and multiply both sides by 450.
373.07.
And label will be newtons. And that is my vertical component.
Why is it that those added together are bigger than 450?
Well, if you use the Pythagorean theorem, they'll exactly equal 450.
For real?
Mhm.
So, what? 251 squared plus
373 squared will equal 450 squared. Yep. Okay.
Remarkable.
So, anyway, questions on that? Think you can handle that?
I think I can do that.
Now, on your homework, they might give you one like this,
TV.
okay, in which they don't give you a diagram. And so you would have to draw one in. And it just says, while digging in his garden, Will pushes a shovel into the ground. So here's the ground, right? Okay, so Will's going to come up here and he's going to put the shovel into the ground with a force of 630 newtons. Okay, at an angle of 70 degrees with the ground. So that means this is 70. So they want you to do the exact same thing. Draw a diagram. Well, we just did right here. Here's your x, here's your y. And then you would solve it the exact same way we just got done doing. Okay? So this is what you need to do for me for tomorrow. On pages 488 through 489, I need you to do 1 through 6 all. I need you to do 13 through 18 all. I need you to do 22 through 34 the evens, number 42, and number 44.